Okay. Do you guys know an owl's favorite kind of math? Algebra. Alrighty. Let's go ahead and get started with, this is day 2 of and compound inequalities. So what I want you to notice first is when you take a look at these equations, just the format of them are different than what you've seen before, okay? And so when you won't see anything like this with or compound inequalities, it will always say or, but you can see them looking like this for an and compound inequality. Now what we can do is we can go ahead and rewrite this. Okay, and remember I've talked about how you always read it with the variable first. So x is greater than 2. So that's how I would rewrite it, is x is greater than 2. It's an and compound inequality because, again, it's in a combined equation, and then x is less than 5. So these two equations are equivalent, and you can write them both ways. And so we'll go ahead and graph this and see if we have a shaded solution. So we have 2, 3, 4, 5. At 2, it's an open circle, arrow to the right. 5, it's an open circle, arrow to the left. And I do have a combined area smack in the middle, so let's go ahead and highlight that. So this is where they overlap. Let's go ahead and try number 2. So number 2, same thing, is you can leave it in this form, or you can rewrite it, and when you rewrite it, make sure you write it with the variable first. We'll see these are equivalent. X is greater than -1, so x is greater than -1. That's how we read it. We have to write in the word and. X is less than 7. Again, we have to write in the word and because we're going to hit or graphs and we have to be clear. You can't assume that I know what you're talking about. So let's go ahead and graph this. So I have -1, 0, 1, 2, 3, 4, 5, 6, and 7. So at 7, I have an open circle, arrow to the left. At -1, an open circle, arrow to the right. And I see a solution where they overlap, and I'm going to go ahead and highlight that. Number 3. So number 3 is this time with this and graph, instead of sharing just the middle variable, just the x on number 1 and 2, they're sharing this entire expression, okay? So when I rewrite this, it's going to be -3 is less than 2x plus 15, or I could write the expression first, and 2x plus 15 is less than 21. And then this is what we're going to go ahead and solve. So I'm going to subtract 15 from both sides. So I have -18 is less than 2x, divide both sides by 2. -9 is less than x, or I could rewrite it as x is greater than -9. Work this one out on the other side. Can't seem to write. 2x is less than 6. Divide both sides by 2. X is less than 3. Oops, I kind of boxed this in a little too early, and I see that I'm writing off of the camera, so I apologize. I think my ladybug got messed with, and it's tilted off. So the way that we're going to rewrite this is we will write this as x is greater than -9 and x is less than 3. So this is one way that you can write it, or you can write it kind of the way that it started, where we have -9 is less than x, which is less than 3, okay? So either answer, either way you write it is acceptable. But again, when we are grading homework, that's kind of the key thing, is making sure that you are doing it correctly. And then the number line, I'm going to run out of room here, so I'm going to squeeze over into number 4 a little bit. I'm going to stick -9 on one end, 0, 3, open circle for each one. X is less than 3, so my arrow to the left. X is greater than -9, arrow to the right. And I see again it overlaps in the middle. And you can see that we're going to do number 4 next time in class, okay? Number 5. Number 5. So I'm going to show you, we're going to solve number 5 like we did number 3, but I'm going to show you that you don't necessarily have to break it apart into 2 inequalities. So it's one of those when we're solving for x and we want our answer to look like what I have boxed in right here. And then we can graph it from here, again, using the idea from problem number 1 and number 2. So to get x by itself here in the middle, we would have to add 8, right? And then you add 8 on both sides of the inequalities. So 5 plus 8 is 13. Drop down less than, negative, less than 15. The last step to solve for x is to divide by -1, and we're going to make sure we do that on each side of the inequality. When I do that, I get -13. We're still solving for, as our last step, solving for the variable, and we're dividing by a negative. Our signs are going to flip, like so. Okay? So I'm just showing you a different way of solving. If you did not, but you can go ahead and keep doing it like we did for number 3. And we'll practice both ways next time I see you in class. The other thing that you can do is from this step is rewrite it if you want to. Just rewrite it with the variable first. So I have x is less than -13 and x is greater than -15. And then we'll create the number line, our line graph. So I have -15, -14, -13. Again, open circles. X is less than -13, so arrow to the left. X is greater than -15, so arrow to the right. And I see where they overlap, and I'm going to highlight that solution. All right, let's go ahead and try number 7 and 8. I'm going to warn you, number 7 and 8 are special cases, so we can kind of write that down along the side that we have some special cases. These are, again, 7 and 8. So for number 7, what I'm going to do is, I glance at this and I see that I have 2x on each side of that inequality. And kind of how I started number 5 is to solve for x. But in this case, when I have more than one variable term, just like how we did equations, we always start with subtracting out our variable terms. So I'm going to subtract 2x from each side. I have -3 is less than 1, which is less than 2. Okay? So when I have this, now this becomes a question. Is -3 less than 1 less than 2? And it is. Okay, so this is a true statement. And then we can write in infinitely many solutions. And I'm just going to highlight my answer here. All right, number 8. So number 8 is another special case. That's why we mark this. I see that I have a variable term on each side of the inequality. And so I'm going to go ahead and start there with my variable term. So I'm going to go ahead and add 6x to each side of the inequality. When I add 6x to each side, I have 3 is less than -5, which is less than -9. Is this a true statement? Is 3 less than -5, less than -9? No, it's not. So we can go ahead and say false. Empty set, no solution, anything along those lines. And I'm going to go ahead and quickly highlight my answer here. Let's go ahead and flip it over. We'll complete number 9. And depending on the time, we might end up doing number 10. So The directions say write a compound inequality that represents each situation, graph the solution. So these are word problems, and we're going to go ahead and label a variable first. So we'll go ahead and start with labeling what x will equal, or n. So it says all numbers that are less than -3 or greater than 7. So x is going to equal a number, okay? Then we're going to write our inequality, and it says a compound inequality. So it says numbers less than -3, so x is less than -3. And then it says or. Now I know we haven't really done much with or, but this is going to be an or compound inequality. Greater than -7, so greater than, I said -7, but I know it's 7, greater than 7. So this is my answer. Yes, I know it has an or, but just to get started on these, this is fine. Let's go ahead and graph this. So I'm going to have -3 on one end, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. And so at 7, I have an open circle. X is greater than 7. My arrow is going to go to the right. And then at x is -3, it's again another open circle, my arrow to the left. This is an OR graph, and you will find out the next time you do notes that this is a solution. And we'll go ahead and highlight. We can talk about this next time I see you in class. And taking a look at the time, let's go ahead and squeeze number 10 in, which will be nice. It gives you a tad more time in class to work on homework. So on number 10, it says all numbers that are at least 2 and at most 9. So again, we're going to label our variable. X is going to equal our number. And numbers that are at least 2 and, so here's that and, at most 9, okay? Another way that we can write this, so this is kind of what we learned today on these notes that we'll practice, is when I have x in the middle, I'm going to have, it is one combined inequality, so x is less than or equal to 2, and that's the way I'm going to write it right here, where I wrote this backwards. I am so sorry. All numbers are at least 2. So at least 2, there we go, at least 2. So x is greater than or equal to 2. Maybe I should have waited to class for class to do this, so I didn't have my mistakes. So anyway, this is, you can write it either way, okay? Make sure you include the word and, or write it as one combined. And then let's just go ahead and graph this. So I have 2, 3, 4, 5, 6, 7, 8, 9. So this time we have closed circles. So I have x is greater than or equal to, so my arrow to the right. X, for the other one, it's less than or equal to, so arrow to the left. And what I have combined, make sure this time you include your closed circles. Alrighty, so that's it for these notes. Thank you for your patience, and I'll see you guys next time in class.